learn rational expression and equations. Rational expression and equations. But first of all, we need to understand, know the definition. What is a rational expression? And a rational expression is defined as a quotient of two polynomial expressions. Polynomial expressions. Well, what is a polynomial expression? Polynomial expression. Well, we know poly means many, nomial means terms, so many terms. So that has to do with things like this: x squared plus 3x plus 1. Now, this is the polynomial expression. We got three terms, but sometimes even one term is considered polynomial. For example, 2x, that's also considered polynomial expression. And of course, you got 3x plus 7 is polynomial. You could have, say, x to the third plus 4x squared plus 7x minus 9. That is also polynomial expression. And so therefore, a rational expression is something like this. A rational expression is we got x plus 7 over x minus 1. That's a rational expression because it's a quotient. That means there's divide of two polynomial expressions. And we could have something like, say, x to the cube, so square plus 3x minus 5 over x squared plus x plus 3. That is also a polynomial expression because it's a rational expression because we got a polynomial on the top, polynomial on the bottom. And we good?
Yep.
And also something like this. So this is a constant term and over x. That's also considered as a rational. And now there are some things which are not rational. For example, square root of x over x. That's no longer rational because this one is not a polynomial. That's called the radical. Okay, so today we have rational expressions, and there is a ways about how do we dealing with rational expressions, but that's kind of beyond today's scope. Today we're going to focus on rational equation. Yeah, so we know the difference between expression and the equation. Expression, just like what we did here, this is expression. And if we put the equal sign, then this becomes an equation. So that's the difference between expression and the equation. Equation always have equal sign. The expression just part of, you can think as part of the equation. Good?
Yep.
Okay. So now we're going to looking at some rational equations. Some can be pretty simple. For example, we could say 1 over x is equal to 3. Well, what is our x? Now to solving that, we just multiply x on both sides. Then this x and that cancel, got 1, and this side is 3x. And then this is the same as 3x equal to 1. Then divide by 3 on both sides, so we find out x is 1/3. Good?
Yep.
Okay. And we could have something like, say, 1 over 2x equals to 2 over 5, then in this case, we're going to multiply both the denominators. So we're going to multiply 2x and also and 5. So 2x times 5. And this side also 2x times 5. So as long as we multiply same thing on both side equation, we know that then that equation is still true. So that's the we call multiplication properties equation. So in this case now 2x get canceled out. We got 5 on this side. On the other side, 5 and 5 cancel out. We got 4x. So now we get the linear equation 4x equal to 5. Then solving that is straightforward. So x equal to 5 over 4. Good.
Yep.
Okay, I'll let you try a couple. 3 over 2x equals 1 over say 2. Let's see what you got. Yeah, you type on the chat. Well, let's see how we do that one. In this case, we just want to make sure that the denominator get taken out. So in this case, we can just times 2x on both sides. And if we do that, then what we have, that cancel, right? And this 2 cancel. So we actually got x equal to 3. Yep. So you got 6 over 2, just need to simplify it. Okay.
Oh, okay. And so then I added the 2 with the 2x.
Yeah. Well, you got it correct, but to not simplify that. So 6 divided by 2 is 3.
Oh, okay. Yep.
Let's try one more. So 3, 2x equals 2/5. Very good. Good job. Okay, now we're going to do something a little bit more complicated, but the same. We use the same strategy. For example, x plus 1 over x plus 3 equals to 2/3. So we want to take out this and that. So what we can do is to multiply the denominators on both sides. And this side, that get canceled. On this side, this get canceled. So now we got 3 times x plus 1 equals to 2 and x plus 2. So we got, then we have to expand it 3 to 3. So 3x plus 3 and equals to this get distributed 2x plus 4. And then minus 2x on both sides. And we got x plus 3 equal to 4 and x equal to 1. Now we find it, then we have to actually go back to check. So go back to the original equation to check, make sure we didn't make any mistake along the way. Sure. Oh, sorry. See, I made a mistake there. That shouldn't be 2, that should be 3. And if I plug in, you can see the problem. X plus 1 over x plus 3. If x is 1, we got 1 plus 1 over 1 plus 3. That is 2 over 4 is half, not 2/3. Well, the reason for that is I made a mistake here because that should be x plus 3. So let's fix that. So that should be x plus 3. Then if that's the case, we got that. This side should be 6. Because 2 times 3 is 6. Okay, so we got x plus 3 equals to 6. Then minus 3 on both sides. Then our x is 3. Okay, now I plug that in. If x is 3, then we got 3 plus 1. The bottom, 3 plus 3. That is 4 over 6, which is indeed 2/3. So therefore, we know we got it right. Good?
Yep.
Okay. Have you try couple? X minus 1 equals to half, and see what you got. Well, you find x equal to 1, but if you plug in, see if that works. It's 1 over 1 minus 1, which is 1 over 0, so it doesn't work. So see where did you make the mistake?
I have no idea where I made the mistake.
Well, just check on the steps, okay? So what we're going to do, yeah, knowing how we made mistake, that is very important. So 2x minus 1, we times that. 2 times x minus 1. And we can see that that got canceled. So this side got 2x. On the other side, 2 and 2 cancel. We got x minus 1. Did you get here?
So I left it, or I did 1 times x minus 1.
1 times.
Yeah, so I put a 1 and then put the x minus 1 in parentheses and then.
And that's fine. That's fine. Because times 1 does not change the value. So that's the same as x minus 1.
Oh, okay. But then I made x, or I made it 1x instead of x. So that's where I changed it
Well,
when I did it.
1x is same as x. Because the 1 times anything, it does not change the value.
Okay.
So once you got here, then we just need to take out this x on both sides. Then the left-hand side is x, right-hand side is -1. So that's how we got x equal -1. Yeah, good.
Not exactly. So when you subtracted x from the one side, it just left it as -1?
Yeah, because this is a -1 is the same as x at -1.
Oh, okay.
Good.
Okay, yeah, that makes sense.
Okay. So let's go back and see if that's the case, because we still need to checking it. If you go back to check, what we have here is top is -1, bottom is -1, -1, -1. So we got -1 over -2. Negative divided by negative is positive, so we got half. So we know we got it right. Good.
Yep.
Okay. All right. Try this one. X plus 3 over x minus 2 equals to 3 over 5.
I'm not sure where I went wrong.
Okay, well, let's see, step by step, we did 5 times x that. Yeah, are you okay with this step?
Yep.
Okay, so this got canceled, this got canceled, right?
Yep.
Then we got 5x plus 3. This side is 3x minus 2. You got here?
Yep.
Then we just distribute that. That's 5x plus 15. And this side is 3x minus 6. Good?
Yep.
Okay, very good. So minus 3x on both sides. What we got is 2x plus 15 equal to negative 6. So we had moved 15 over, so minus 15. Then we got 2x equal to negative 21. Yep. Are you okay here?
Yep. I just didn't know what to do because I had the 15 and I didn't realize you had to bring it down with the 2x and then subtract it to the other side.
Okay,
I was lost on what to do with the 15, but now it makes sense.
okay. Then we divide by 2 on both sides. Then x is negative 21 over 2, right? Yeah, we good on here.
Yep.
Okay, so same, we need to go check. Go back. So if you go back to check, we want to check this equation. So we got negative 21 over 2 plus 3 over negative 21 over 2 minus 2. Okay, so since we're dealing fractions, we want to have the same denominator, so it's negative 21 over 2 plus 6 over 2. The bottom, negative 21 over 2 minus 4 over 2. And so therefore, drop down here. So we got negative 21 plus 6 over 2 and divide by, this is called the complex fraction over 2. Yeah, we're good here on this one.
Yep. And this is just checking it, right?
Yeah, we're just checking it.
Okay.
So now we got negative 15 over 2 divided by negative 25 over 2. Well, the division is the same as multiplication of the reciprocal. So this is the same as negative 15 over 2 times the reciprocal of that, which is 2 over negative 25. And 2 and 2 cancel, negative, negative, positive. So we got 15 over 25. Now, 5 has a factor of, 15 has a factor of 5. 25 also factor 5. So we divide by 5 on the top and bottom. We got 3 over 5. So we know we got right. Good.
Yep.
Okay, so this is one kind of rational equation. And we have another kind is that kind of like this equals to 3 and x plus 1. So they're on a different side. And we do the same thing. Go x plus 1 times x minus 2. And here is x plus 1, x minus 2. So x minus 2 cancel. We got 2, x plus 1. The other side, that cancel. We got 3, x minus 2. Okay, are we here? Good.
Yep.
Okay, then we just distribute. We got 2x plus 2, then 3x minus 6. And I like to dealing with positive numbers, so I'm going to flip this one. Make that into 3x minus 6 equal to 2x plus 2. Because this is equation, so we can do that. Doesn't matter which side they are on. So in that way, I just dealing with positive variable. So we got x minus 6 plus 2 equal to 2. Then do the same thing as before. So it's x equal to 8. Now we got that, then we have to go back to check. Let's see if that's the correct. So back to the original equation, which is this. Okay, now on our left-hand side is become 2 over 8 minus 2. And we want to know if that equal to the other side, which is 3 and 8 minus 1. And on left-hand side, 8 minus 2 is 6. So we got 2 over 6. And we check if this equal. This is 3 over 9. Well, this side is 1 over 3. That side is 1 over 3. So that's the case. So therefore, x is equal to 8. Yep. Are we good here?
Yep.
Very good. So let's try one. 1 over x plus 3 equals to 1 over x minus 4. Oh, there is a 2 here, sorry. Okay, so you think x is negative 10? Hello?
No, maybe just x is 10.
X is 10. Well, have you checked?
No.
Oh, you need to checking it. Go check it and see what you got. See if they are equal. What do you got?
They're not the same.
Right. Well, let's see where we went wrong. We're going to multiply x plus 3, then x minus 4, and same sign on x plus 3, x minus 4. So x plus 3 cancel. We got x minus 4 on this side. On the other side, that and that cancel. We got 2 x plus 3. Yeah. Did you get to here?
Yep.
Okay, then that equals to 2x plus 6. So I'm going to flip that, become 2x plus 6 equal to x minus 4.
Can you not flip it? Just so,
You
because I
can,
didn't flip it.
you can, then you have to dealing with negative. So if you minus x on both sides, minus 2x on both sides, then you got negative x minus 4 equals to 6, right?
Yep.
Then add 4 on both sides. Then we got negative x equal 10. Well, which means x is equal to negative 10, right?
Oh, okay. So I just didn't. I got negative x equals 10. I just
Right.
didn't give the negative to the 10.
Yeah. Well, negative
And
x
so
equal 10 is the same as x equal to negative 10, right? Are we good on that?
yep.
Okay, so now we can check and see if
But
that,
if I would have flipped the problem, I wouldn't have had a negative.
right, you don't have dealing with negative.
Oh, okay.
So that's why I flip it. Because if you flip it, what you got here is 2x plus 6 equal to x minus 4. We minus x, we got x plus 6 equal to negative 4, then minus 6, so x equal to negative 10. Good?
Yep.
Okay, so now we're going to check and see that equal. And the first one, of course, is 1 over negative 10 plus 3. We want to see if that equal. That's 2 negative 10 minus 4. And on the left is net 1 over negative 7. On the right is 2 over negative 14, which is indeed 1 over negative 7. So that's the correct answer. Yeah, good.
Yep.
Okay, now we're looking at the third type of problems. There's x plus 6 over x minus 5 equal to minus 5. Now this, we only have one denominator, which is times x on both sides. And what we got here, this time that x squared, and this time that just gave us 6, get negative 5x. So what we got here, and then add 5x on both sides. We got x squared plus 5x plus 6 equal to 0. Yep, are we good here? Hello?
Yep.
Okay. Well, this is just quadratic equation. So we have to do factorization. So we break 6 into 2 and 3. And 2 plus 3 is 5. So that's good. So what we got here is x plus 2 times x plus 3 equal to 0. Now, if that's the case, then we got two possibilities. One is x plus 2 equal to 0, and that give us x equal negative 2. The other one is x plus 3 equal to 0, and that give us x equal negative 3. So we got two solutions. And are we okay here for the factorization?
I think so.
How do we get
Uh,
from here to this step?
Um, I guess what I'm confused about now is I don't remember how you went from x plus 2 equals 0 to x equals negative 2.
Oh, from here to here?
Yeah.
Well, just minus 2 on both sides, right?
Oh, okay. Yep. Yep.
Good.
That's right.
Yeah. Good so far?
Yep.
Well, we still have to check. Okay, we'll go back to original. We check x equal negative 2. So what we got, which is negative 2 plus 6 over negative 2. We want to see if that equals negative 5. Well, this is negative 2. 6 divided by negative 2 is negative 3. We hit it, it is negative 5. So we know this is the correct. And we want to check the second. Sometimes one of them is not valid, but what we get today, that's okay. For this one, it's okay. We get negative 3 plus 6 over negative 3, and that's negative 3 minus 2. It is equal to negative 5. So both are true solutions. Okay.
Yep.
Okay, so I let you try one. X plus 1 over x equal to 2.
And when I checked it, it came out wrong, but I couldn't figure out why. So,
Well, let's see. We multiply x on both sides. And that give us x squared plus 1 equal 2x, right?
yep,
Okay, we minus 2x on both sides. So we got x squared minus 2x plus 1 equal to 0, right?
yep,
So now we know 1 can be made -1 times -1. And -1 times -1 is 1. -1 plus -1 is -2. So we know that we can make that into x minus 1 times x minus 1 equal to 0, right?
yeah, but that's not how I did it. I had x plus 1 and x plus 1 equals 0.
Well, if you x plus 1, that won't work because when you expand it, you won't get this. This actually is x squared plus 2x plus 1. Good. But we have negative here. Yeah.
Okay,
You see that doesn't work, right?
yep,
Okay. So, and because we're going to break 1 into 2 numbers and add together should give -2. So the only way we can break it is -1 times -1, right?
yep,
So therefore it is x plus 1 times x minus 1 times x minus 1 equal to 0. Good.
but what would your answer be?
Well, how do we solve this? Remember when we saw quadratic equation. So when this minus this equal to 0, then the only possibility here is x minus 1 equal to 0, right?
Yep,
So therefore, if that is true, then x has to be 1, right?
yep,
Yeah, so in this case, we actually only had just one solution because this two are exactly the same. So our answer is x plus 1, and we can check. If you go check back,
but how would you know that in this case that both of them are the same, so you just get one answer?
well, both of them is the same, right? Both are x minus 1.
Oh, okay, so since the fact that they're both
Yeah.
-1,
Mm-hmm. Yeah, you only just
okay,
one solution. Good.
yep,
Yeah, like sometimes you got x minus 1, x minus 2, then you got two solutions. One is x will be 1 or x is 2, right? Do you see that?
yep,
Yeah, that's why you have two, because they are different. Here we are the same, so we only got the one solution. Then we can plug in is 1 plus 1 over 1. That is 1 plus 1 is 2. So we know we are good. Good.
yep,
Okay. And we're going to try another form is this 1 over x minus 1. We'll do the same thing is x minus 1, x minus 1 both sides. And that can, so we can see that the process is the same. We just cancel out the denominator. Then we got x squared equal to 1. So in that case, we got x equal to square root plus minus root 1. Then x equal to plus 1 and x equal to -1. Good. Yeah. Are we good here?
I'm not sure exactly.
Well, if x is square equal to 1, what x can be?
1
or negative 1,
x.
right?
Oh, okay, yeah.
Negative 1 squared is also 1, right?
Yep.
So that's why you have two solutions, but we want to go back to check and see if that actually work. Well, now, and if you plug in x equal to 1, we just see the problem right away. This is 1, this is 1 minus 1. We are doing 1 over 0, and that is big no-no. And we cannot divide by 0. So this is not a valid solution. Then we look in the second one. The second one we got negative 1 squared, negative 1 minus 1. We got 1 over negative 2, which is negative half. This is on the left-hand side. Right-hand side is 1 over negative 1, which is negative 1 half. So left-hand side 2 equal to right-hand side. So therefore, this is the valid answer. Good.
Yep.
Okay. All right. So we have to try the last one. X squared over x plus 2 equal to 4 x plus 2. That's what you got.
I've gotten stuck.
Well, what do you do first?
I'm trying to multiply both sides by x plus 2.
Very good. Then what you have? X squared equal to 4, right?
Oh. Now I do.
Okay.
Okay.
Then what's your X?
X equals -2 or
Yep, true.
+2.
Right. Well, now we're going to plug in. If it's positive 2, what we got here on the left is 2 squared over 2 plus 2. On the right is 4 over 2 plus 2. And 2 squared is 4, 4 over 4. And on the left, on the right-hand side, it is 4 over 4, so it's good. So this is a good one. But -2, we have a problem because x plus 2 is negative 2 plus 2 equal to 0. So we cannot divide by 0. So this one is not a valid solution. Good.
Yep.
All right. Okay. That's what we have for today. Okay.
Okay.
All right.
Thank you.
No problem. Bye.